Today we are going to unlock 4 keys to produce magical results using Fermat's little theorem. And let me tell you one thing today, that this topic is so easy to understand, and make it a habit to try, adapt and learn from this video, and keep watching it every small intervals so that your solutions will be a click away. And let's go straight into the point. And today's topic is from Fermat's little theorem, and this is from number theory, and this is related to MFCS, DMS and DMGT. And in my previous video, I taught you about the Fermat's little theorem proof, and in today's video, I am going to solve the problems related to this theorem. And hope you all guys will take time and make time so that these problems are so important. See here, according to the Fermat's little theorem, the problems here is we have to find the remainder. So for the question 2 power 16 modulo 17 and 2 power 50 modulo 17 and 4 power 532 modulo 11 and 5 power 18 modulo 19 and 8 power 30 modulo 31 and 3 power 41 modulo 7. So Fermat's theorem is very useful to find the remainder, as this number is so big. So when it is divided by 17, so the remainder we have to find. So according to our Fermat's theorem, we have, if p is a prime number, as you know that if p is a prime and a is an integer such that p does not divide a. So p shouldn't divide a. Then a power p minus 1 congruent to 1 times of mod p. So here this 1 will be the remainder when p is divided by. So this one a power p minus 1. Or else, so if a power p congruent to a mod p. So here if p divides this term, so the remainder is a. So according to the Fermat's theorem, so it will be very easy. So whichever the number, very big number, so if you multiply with a number, the remainder is obtained using this formula, and we have to use this formula to get the remainder of each of the following question. See here, the first thing is 2 power 16 modulo 17, as 2 power 16 is a very bigger number, and 17 if you divide with a prime number. And see here, so first thing is I am taking a value as 2. So a value as 2 and p value as 17. So according to our Fermat's theorem, so we have a formula ready that a power, this is p minus 1. This is congruent to, this is 1 mod p. Clear? So if I substitute here in this, so if I substitute a value is equal to 2. So if I substitute 2, what is our prime value? Prime number, that is 17 minus 1 congruent to, this is 1 mod. What is rp? This is 17 again. So this will be 2 power 16. This is congruent to 1 mod 17. See here, if you observe this question, 2 power 16 modulo 17. So when 2 power 16 is divided by 17, so the remainder so obtained according to our problem here is 1. So here our remainder value. So the remainder we got as, the remainder value is equal to 1. And in the second question, this is 2 power 50 modulo 17. So here also the same case, I am taking a value as 2 and the prime number is equal to 17. So as you know that, so we have a formula ready that a power, this is p minus 1. So this is congruent to 1 mod 7. So 1 mod, this is p. So here if I substitute the same thing, so a value is equal to 2. So this is 2 power, p value is equal to 17. 17 minus 1 congruent to, this is 1 mod. What is our p value? This is 17. So this will be 2 power 16 congruent to, this is 1 mod 17. So I need 2 power 50 here. So in order to raise 50, so what we have to do? So this can be, so 50 can be obtained by, in terms of 16 if I write, that is a 16 into 3, 48 plus 2. Clear? So I am raising this power 2. So 3 cube times. So cubing on both sides. This is 1 cube into modulo, this is a 17. So this will be 2 power 48 congruent to, this is 1 cube is 1 modulo 17. Clear? And next one, I need 2 square in order to get 50. So I am multiplying on both sides with 2 square. So this will be 1 into 2 square. This is modulus of 17. So if you see, this will be 48 plus 2. This is congruent to 2 square. This is 4 into this value is mod 17. So if you see, this value will be 2 power 50 congruent to this is 4 mod 17. Clear? So we got when 2 power 50 modulo 17. So the remainder when 2 power 50 is divided by 17, we got the remainder. So this will be the remainder. So the remainder will be 4. So in this case, so our next question here is, the next question is 4 power 32 modulo 11. See here, this is 4 power 532 modulo 11. The third question here is 4 power 532. This is mod 11. So clearly if you see, a value will be, so if you see a value is equal to 4 and our prime number value, the p value is equal to 11. As you know that according to our Fermat's theorem, we have a power p minus 1 is congruent to 1 into this is mod p. So if I substitute the same thing here, a value as 4. So this will be 4 and what is a p value? This is 11 minus 1 congruent to 1 into what is that p value again? So this value is 11. So this will be 4 power 10. 4 power 10 congruent to 1 into this is mod 11. So when 4 power 10 is divided by 11, we got the remainder as 1. So we need 532 as a power. So this can be written as, so this is 530 plus 2. 530 plus 2. So this can be written as 53 into 10 plus 2. So 532 can be written as this one. So we have already 10 as a power. So I am raising this power to, I am multiplying or raising the power to 53 on both sides. So this is also 53. This is modulo 11. Modulo 11. So if I multiply, so this will be 50 into 10. This is 530 congruent to 1 power anything is 1. I am leaving as it is. This is modulo 11. Clear? And I need 2 here. So for 552 I need 2. So that's why I am multiplying with. This is 530 into I am raising the power. So this is 4 square I am multiplying on both sides. This is 4 square into modulo 11. So this will be, so if I add up these two, this is 530 plus 2 which is congruent to 4 square, it is 16. This is modulo 11. So this is 404 power, this is 532 congruent to this is a 16 modulo 11. So if you observe when 4 power 532 when divided by 11, so we'll be getting the remainder as a 16. So according to the Fermat's theorem. So this is also so simple if you understand. So first of all we have to take a is equal to 4 and the prime value as 11. So in this formula Fermat's theorem, Fermat's little theorem, if you substitute a as 4 and p as 11. So after raising the power and after balancing, in order to get 532, so we got the remainder as 16. And our next question, the fourth question here is also so simple, that is 5 power. So this is 5 power 18 modulo 11. So this one, the fourth question here is, this is 5 power 18 modulo 11. So we need the remainder when 5 power 18 when divided by 19. So we need the remainder. So therefore here a value is equal to, clearly a value is equal to 5 and our p value is equal to 19. As you know that according to the Fermat's little theorem, this is a power p minus 1 is congruent to 1 mod p. So this is 1 mod p. If I substitute everything here, this will be 5. And what is the prime value? This is 19 minus 1 congruent to 1 into mod. What is our p value? This is 19. So obviously, so this is 19 minus 1, the 18 congruent to this is 1 mod 19. So 5 power 19 when divided by 19, we got the remainder value as 1. So here is the remainder. The remainder value is 1. And clearly our fifth question here is, so if you see the fifth question, so what is the fifth question here? So 8 power 30 modulo 31. So here 8 power 30, that is modulo 31. So here what we have to do? So again we need the value. So I am taking a value as 8 and p value as 31, and again I am applying the Fermat's little theorem. According to the Fermat's little theorem, a power p minus 1 is congruent to 1 into this one is mod p. So here if I substitute a value as 8 and here p value is 31 minus 1 congruent to 1 into this is mod. What is that p value? This is 31. So this value will be 8 power 31 into this value is mod 31. So if you observe 8 power 31 divided by 31, so what is the remainder left? 1. So here the remainder value is, so the remainder value is 1. And finally the sixth question here will be, see here, this is the sixth question. 3 power 41 modulo 7. So this is 3 power 41 modulo 7. So here it's very clear that we have to take a value is equal to 3 and our prime number is equal to 7. So according to our Fermat's little theorem, as usual, that is a power p minus 1 is congruent to 1 into this is mod p. Mod p. If I substitute each and everyone here, everything here, so a value is equal to 3. What is our p? That is a 7 minus 1 congruent to 1 into this is mod. P value is equal to 7. So this will be 3 power 6 1. This is modulo 7. So we need 41. So 41 can be obtained as a 6 into 6, that is 36 plus 5. 36 plus 5 is 41. And therefore I am raising the power, that is a 6. 1 power 6, this is modulo 7, and this will be 3 power 36 modulo 1 power anything is 1, and this is modulus of 7. So again I need 5 here, therefore 3 power 36 into 3 power 5, and here also this is 3 power 5, this is modulo 7. So this will be 3 power 41 congruent to this is 3 power 5, this is modulo 7. So here when 3 power 41 when divided by 7, the remainder left is 3 power 5. And this is how we have to solve. This is also so simple if you follow the Fermat's theorem. So my previous videos are already in the playlist, and if you watch those videos in the playlist, it will be very helpful for your preparation, and you can do any problem of this kind, and hopefully this video will be very helpful and useful. And please pass it on to your siblings and whomever you like the most, and all the friends, as many as friends as you have. And thank you so much, and your subscription is very important, and please go through all the videos, and definitely it will be very helpful. And thank you so much for watching and staying till the end.